All right, welcome to Lab 2. Let's talk about it. So I'll go through this little write-up with you, and then you can get started. So this one's about command line arguments as well as system calls, and so it's just getting practice with all the stuff that we've been doing recently in lecture. So get that starter code wherever you want it, and here are the 4 files that you will see. So there's 3 different assembly files and a make file, and so there's going to be like 3 real parts to the lab. Okay, the first one revolves around going through the command line arguments. So printing out everything in argv. And so I'd like you to edit argv.s and make an assembly program that just iterates through every single command line argument and prints each one out using printf. All right. So remember that in C, your first argument is argc, and then your second argument is argv. So that means argc is going in W0 for us in assembly land, and argv has been placed in X1. Okay, so that's how that's going to work. I've given you most of the scaffolding. You'll need to add stuff to your data section, of course, but I've done the weird saving of things on the stack and then also returning 0. I've actually done a little bit extra that I didn't show in lecture. So I'm saving LR, sure, but I'm subtracting more than just 16 from SP this time. I'm subtracting 32 because I actually need to store a few extra things on the stack. I would like you to use X19 and X20 in this program. You're going to need to use these guys because they're saved registers. They're guaranteed to not be messed with across function calls. So printf will not be clobbering these values because you're going to need to keep these 2 values safe. All right, I'll explain that in just a second later, but let me get through what's going on here. Here's kind of how your program should work. You got to compile with the make file. You say make argv, it'll take care of making an argv executable. And then every time you run it with different command line arguments, here's kind of the output you should see. It should just loop through everything in argv and print them all out on a new line. That's the output that you should see. Okay, so your goal is essentially this. Like you want to iterate through all of argv, which is an X1 right now, and print out every element. You know that you're done because argc is telling you how many you've got. Print out each one on a separate line with a call to printf. Okay? And here is my hint to you. All right? The reason I've done these 2 lines is because you should save at least 2 things, right? You're going to want to save argc, let's say in X19, and argv in X20. All right? Because every time you call printf, first of all, when you make the call to printf, you're going to have a format string and the thing you want to print usually, and that's going to kill what's in X0 and X1. You've just gotten rid of argc and argv if you did that, right? So you better save them in a safe place. That's what those are for. Those are your saved registers. Printf cannot touch them. So save argc in X19 and argv in X20. They're guaranteed to be safe there across calls to printf. And yeah, just keep on looping. Print whatever you see at your current place in argv with printf, and then keep on looping until you've got nothing left. So until, like, keep subtracting from argc and X19, keep subtracting until it's 0, because then you're done. And you always want to keep advancing to the next C string. So think about how you need to add to your value in X20. What's the address of the next string in my argv array? Okay, so that is my set of hints that I have for you for this first part of the assignment. And then we just return 0, restore everything back at the end, restore the old values of X19 and X20, of course, because our job is to, if we use them, we better restore them. That's what printf is going to do as well. So that's how the ABI works for this part. So yeah, that's the first part of the lab. Print all those command line arguments, and then I want you to get some more practice with system calls and mixing those with the C language. So just like we were doing with what was it? Just like we were doing with our 2 examples today. Dun, dun, dun. Oh, this is the wrong file. Just like we were doing the process ID and the sysinfo stuff, you're going to do some of your own. So you might want to go to this link and look at the ones I'm asking you to do. But here's what you'll be working on. I want you to get your user ID using a system call. All right? Syscall's easy. This one's an easy one. So there is a system call for that. Let's look at that file. Syscall is easy.s. Dun, dun, dun. So you go to this page. You're going to do the get UID syscall. All right. And there's 2. There's one called get UID 32. You just want the get UID one, the normal one. So go find that one. It will be on this page, get UID, not the 32 one, that doesn't exist, just get UID, this system call, figure out the number, right? And it takes nothing. So you're just going to call it just like the get PID one. And so you're going to call get UID, and it will give you back the user ID for your user, and it will place it, it's an int, it's a 4-byte value, so it's going to be placed in the W0 register. All right? So it's your job to use that knowledge, make the syscall, get the value back, and print it just like I was printing the process ID. So you can steal a lot of that code. Okay? And yeah, that's how that works. You want to print it as an unsigned value for sure. And then a new line at the end. So for example, do I give you an output example? Like here is, for example, what you might see, like this is your user ID. And you can compare that, though there is a way to check your answer. If you just type like echo $UID on the terminal, that'll tell you your user ID on the system, and it never changes. There's also an ID command that tells you a lot of cool stuff. So yeah, that's how that works. Yours is different than mine, of course, because you're a separate user. So your value will be different there. And yeah, I think that's it. This will be very similar to the print the process ID system call example from class. So definitely steal a lot of code there. Again, you'll use the makefile to compile. All right. And then the last one, the syscall is hard. I promise it's worth the effort because it's so cool. Oops, I don't want to change anything. It's so fun. It's going to get the time. All right, so you're going to make the syscall called get time of day. All right, so that's this one over here, get time of day. It'll be this one. Figure out the number and all that. But here's how it works. Essentially what it does, it takes some stuff and it's going to give you back the current number of seconds since January 1st, since midnight on January 1st, 1970. That's just what everybody agreed. That's how we're going to store time inside of a computer. It's a bit of a long story, but that's how that works. Definitely read all the comments, do all the other ones first before tackling this one. It's going to be just as hard as the sysinfo one. Okay, so syscalls hard.s. Definitely look through the comments. You're going to use this syscall, get time of day. It takes two things, a struct time val pointer and a struct time zone pointer. All right, but what you're going to do is not worry about the time zone one. All right, you're going to need to make space for a struct time val, and it's going to set that just like the sysinfo one, set the struct sysinfo. So you need to make enough space for this, so you're going to have to make like a dummy C file to figure out like how big is this, how much room do I need to make for myself in the data section. So that's important. You need to figure that out. All right, and then you'll be able to go inside of that time val struct and get the seconds out. All right, that's the goal there. So this will set. Let me go here first, maybe. So yeah, definitely read all these comments. Set the time zone to the null pointer. That second argument, we don't care. This pointer, set it to null when you make the system call. So null is the 0 address. So just pass 0 along in x1 as you make the system call. But it's x0 actually needs to hold the address of your struct time val, because that's getting set, and it's going to hold these things. All right. So you're going to go in and get the TV sec part. So you're going to have to figure out like how big is this? Is this 32 bits? Is this 64 bits? Because that'll tell you whether you need to read it into a W register or an X register. That's very important. And then you get that, and you're going to print out the number of seconds that you see. It'll be an integer value, but you need to figure out, is it a 4-bit thing or is it an 8-bit thing? All right, and you'll have to print it differently depending. So get that working, and get the value out. And when you run it, here's kind of what I want you to do. So you make the syscall, figure out the number of seconds, and every time you run your program after you compile with the makefile, every time you run it, it'll give you back the number of seconds since January 1st, 1970. And obviously that number is just going to keep going up each time you rerun the program. So you can check if you're doing the right thing by like dividing this and figuring out like how many years have passed and seeing if it like gives you the right amount. Okay, so that's going to be the harder part of the lab this time. Okay, So yeah, your job is to like make a dummy C file like I was doing in lecture, like figure out how many bytes is this struct time val, how big is the thing I want to extract, all that stuff. How big is the time t? And then you'll have to make that much memory available in the data section, and you give its address in the syscall. All right, and then it'll happen, and then you need to extract the time t part, and yeah, print it out as a big value. All right, my hint is it's going to be more than 4 bytes, I think. All right, so there's that. Once you get it, print it out, and then you can do some math to confirm that it's right. Like add this computation to 1970 and see if it gives you the current year that we're in right now. So I think that's all that I wanted to say. Read the comments. I promise it's going to help you. Go back to my example with sysinfo because it's very similar to that. But yeah, just remember that when you're making that syscall, this needs to be set to something. You need to give a concrete address here, but set the time zone argument, the thing in x1, to null, the null pointer, which is 0. Just pass along 0 to right there. All right? So 0 is going to go in x1 when you make the system call to get time of day. All right. So I think that's everything that I wanted to say about your lab. Do yell at me if you have any questions about anything. Here's how you'll turn them all in, all those files that you messed with. And yeah, just make sure to check your grade, make sure you got full credit before you stop submitting, I guess. So yeah, good luck, and I will see you next time.